The last page of the notes for today, on example number 8, it says to find the distance of segment AB given the coordinates of point A and the coordinates of point B, and they want us to round our answer to the nearest 2 decimal places. Let me just check the focus on this. There we go, that's a little clearer. So they tell me that A is at 2, 5. So let's graph that one on the graph. 2, 5 is right there. And then they tell me that B is at -2, -3. Anytime you have 2 points that are horizontal or vertical from each other, you don't have to do the distance formula to figure out how long the segment is. You can just count the boxes. But when they're on a diagonal like this, you can't just count the boxes. So this question is an introduction to the distance formula. What I'm going to do is I'm trying to figure out how long it is from here to here. So what I'm going to do is I'm going to drop a dashed line coming down this way, and then I'll drop a dashed line coming across this way. And so what happens is when you draw on those 2 little dashed lines, you'll see that the shape that the dashed lines form, this segment that you're trying to figure out how long it is becomes the hypotenuse of a right triangle. So I create this right triangle. I'm going to put the little box on it so that you remember that it's a right triangle. Here's my part that I'm trying to find out how long it is, so I'll call that side X. And then this side and this side become the legs of my right triangle. So from A to the corner is 1, 2, 3, 4, 5, 6, 7, 8. So this side's 8 long. And then from B to the corner is 1, 2, 3, 4. So this side is 4 long. So if I wanted to figure out how long this side was, one way that I could figure out my answer is I could use the Pythagorean Theorem. So I drew a right triangle on my picture, and now I can plug the numbers into a squared plus b squared equals c squared. Just remember that this side x has to be your hypotenuse for your c. 8's a leg, 4 is a leg, so I'll call 8, I'll call 4 my a and I'll call 8 my b. It doesn't matter which one's which, but this one has to go in for your c. So I'm going to say 4 squared plus 8 squared is equal to x squared, and x is the one that I'm trying to find. So I'll get 16 plus 64 is equal to x squared. So 80 is equal to x squared. And then to get the x all by itself, once I'm at this point, I'm going to take the square root of both sides. 80 is one of the special square roots. So 80 is 16 times 5. Let's just double check that. I guess I should have said 80 isn't one of the special square roots, but 80 is one of the square roots that has a special one or a perfect square inside of it. So when you break 80 up into 16 times 5, and I just double checked and made sure that was right, the 16 can come out as a 4. So I could say x is equal to 4 square root 5. Remember, the 4 came out, but the 5 stayed stuck inside. But this question also wanted me to round my answer to 2 decimal places. So if I type that into a calculator either from here, or if I type it into a calculator from here, I get that the length of the segment is approximately 8.94. And so I could write it both of those ways. So I was trying to figure out how long the segment was, and so I did it like that. Anytime you're trying to find the distance between a segment that's at a diagonal, this is one way that you could find your answer. The distance formula is a formula that lets you do that without necessarily always needing to draw the triangle on the picture or have a graph at all. It says that the distance is equal to what you get when you subtract the x's from one another and you square it, and you subtract the y's from one another and you square it. And then you take those 2 squared differences, you add them together, and then you take the square root of the whole thing. It's like in this formula, what's basically been done is they took the Pythagorean theorem and they got it down to the part where this letter that's all by itself is basically like having the c all by itself up here. So the distance formula is just, it's derived from the Pythagorean theorem. You can remember this formula if you want. This one's the official distance formula. It's the more formal of the 2 formulas. But you can also choose to remember this one if you wanted to. This says you take the x's and you square them, you take the y's and you square them, you add them up. This little triangle right here is delta. It's a Greek symbol that means change. So you're actually squaring the change in the x's and squaring the change in the y's. You're adding them up and you're taking the square root. So this is really just the Pythagorean theorem with the c all by itself, except they choose to use d. When we do the distance formula, you get to decide how you want to set these up. So you can figure out how much the x's change and figure out how much the y's change, Or you can plug them into the formula. So you could do x1, y1, x2, y2, and do x1, y1, and x2, y2, and plug them into the long formula. But a lot of people prefer not to do it that way, and they prefer just to think about how much they change. It's really up to you. So what I'm going to do on the paper is I'm going to use this version of the formula, but feel free to use the first one if you'd like. To get from -6 up to -2, the x's go up by 4. And to get from +2 down to -3, the y's go down by 5. So that means that my x's change by 4 and my y's change by 5. My change in x is 4, my change in y is 5. So to figure out the distance, or how far apart these two are, or the length of this segment, it says I'm supposed to do it without graphing coordinates, by the way, which is why I didn't draw a graph. I'm going to plug it into the formula. So I'm going to say that the distance is equal to the change in x's, which was 4, and then the change in y's, which was 5. So that's going to give me 16 and 25. When I square them, they both turn positive. So it would give me the square root of 41 when I add those up. Now the square root of 41 doesn't simplify. It doesn't have any numbers hiding inside of it. So I'm just going to take the square root of that. They wanted me to round my answer to 2 decimal places. So I could say the distance was the square root of 41, or it's approximately 6.40 if I round it to 2 decimal places. So the square root of 41, it's 6.403, and the 3 would make the 0 stay as 0. So when they fill in the blank right here, I'm going to write 6.40. And technically this should have an approximately symbol, not an equal symbol, because this is an estimate. But both of these answers are correct. So you could give this answer in both of those two ways. And then for this last one, I'll do the same thing. To get from -1 up to 3, the x's go up by 4. And then to get from 2 to 4, the y's go up by 2. So on this one, my change in x is 4, and my change in y is 2. It doesn't actually matter whether the changes in x's and y's are positive or negative of whatever value they are, because you're going to square them. And when you square them, like when I squared the -5, it turned into +25. So it always stays positive. All right, so this one's going to give me the square root of 20. And then 20 is one of the special square roots because 20 is 4 times 5, and the 4 comes out as a 2. So I'm going to get that the distance between these 2 points, or the length of that segment, is 2 square root 5. And when I type that into a calculator, it's going to give me approximately 4.47. And so again, this should be an approximately symbol. But 4.47 would be the distance between those 2 points graphed on a graph. Before we move on to this last question, students tend to mix up distance and midpoint. There's formulas for both of them, but students tend to get them backwards and they flip them around. So I just want to remind you that if you're finding the distance between two things, you're measuring how long it is. So your answer is an answer of measurement. Your answer is not a point. What was different was on the previous page, when we were going through and we were finding midpoint, midpoint is a point, midpoint. So your answer for midpoint, if you're finding the midpoint or if you're finding one of the coordinates, actually, these really shouldn't have equal signs on them. If you're finding the midpoint or if you're finding one of the coordinates, then your answer is a point because that's a point. But in these questions, you're actually finding out how far they are apart, so it's a measure of distance. So it's just a single number. Okay, that's definitely something that students confuse. So last but not least, example number 10, it says the endpoints of 2 segments are given, and they want us to find out how long each one is. So we're going to figure out how long this one is and figure out how long this one is. And then it says to tell whether they're congruent, and we're going to round our answers to 2 decimal places. So I'm going to have to figure out the length. So I'm figuring out the distance. I'm not trying to find the middle of either one. Let's do PQ first. So P is at 4,3. And then Q is at -1,6. So that's point Q, that's point P. And we're trying to figure out how long that from that is. Now, I should point out that you can just draw on the right triangle, and you could just solve this using the Pythagorean theorem. That's perfectly fine. What I'm going to do is use the distance formula, but the distance formula that I use, this one right here, is just an adaptation of the Pythagorean theorem. So here we go. We need to do 2 distance formulas on this one to figure out how long each piece is. Two distance formulas. And so here I go. For the first one, I'm going to say that from P to Q is, and now I need to check and see. So to get from the X to the X, I went down by 5. And to get from the Y to the Y, I went up by 3. So my distance formula is going to say my X is changed by 5 and my Y is changed by 3. So my length from P to Q is going to be the square root of 25 plus 9, which is the square root of 34. 34 doesn't have any perfect squares hiding underneath it, so I'll just convert that to a decimal. So it's approximately 5.83 when I round it to 2 decimal places, like the directions to the question said. So from P to Q is 5.83. If RS is congruent to PQ, it means that when I do this next one, I have to get the same answer out. So it has to work out to be exactly the same thing, the square root of 34. So let's see. To get from X to X, I minused 4. And then to get from Y to Y, I added 3. So from R to S, my X is changed down by 4, and then my Y is changed up by 3. So that's going to be 16 plus 9, which is the square root of 25, which is 5, because the 25 is a perfect square and it comes out. So from R to S is 5. So what you conclude from this is that the two, oh, I never graphed that one. I'll do that in a second. What you conclude from this is that while the two segments are almost equal to each other, and if I had graphed this one like I was supposed to, sorry about that, that would go here, that would go here. And so this one would be R and this one would be S. Even though they're really kind of close to looking like they might almost be the same length, the first one's just a little bit bigger. So they're not congruent. And that also means that you don't put the double, or the single or double little lines on the picture to show that they're congruent, because they are in fact different lengths.